Hello, grade 9 learners.
Oh, come on, guys. Now hold on.
Morning.
No, why?
Well, I wanted to play superheroes, but no one was with me.
Oh, that's not Show these guys the beauty of
Right, good morning, grade 9 learners. All right, may you unmute yourself so that I can hear you, so that we can start. Otherwise, I'm a little bit late. I had some technical issues here. So, morning.
Sir.
All right, thank you so much. Now I think I can now begin my lesson. Sorry, I'm just a little bit late by about, I think it's about 9 minutes. I had some issues with my laptop here. Right, anyway, we are going to look at parallel circuits. That's electrical parallel circuit. So I'm going to mute you all so that we won't experience some disturbance. Right. So if you still remember, boys and girls, last week, that was on Wednesday, we had a lesson on series circuit, whereby we were looking at components that are connected in series, right? And if you still remember, whenever we are talking about series connection, we are talking about electric components that are connected one after the other, right? And we said then that if cells are connected in series, the voltage increases, right? Which means the total voltage for the circuit is equal to the sum of all the voltages of cells that are connected, right? Then we also talked about series connection of resistors, whereby we said the more the resistors that you connect in series, the higher the voltage, which simply means the total resistance for a circuit whereby resistors are connected in series will be the sum of the resistance of all the resistors, right? Then we also talked about current. And in current, we said current is the same throughout the circuit. Doesn't matter where the ammeter is connected. But as long as it is a series circuit, current is the same at any point in the circuit, right? So that's what you must know. Then we also mentioned Ohm's law, where we said whenever we are dealing with series circuit, for us to do some calculation, we use what we call Ohm's law. And Ohm's law is just a formula which is used to calculate resistance or to calculate current or to calculate voltage, whereby we say voltage is equals to current multiplied by the resistance. That's Ohm's law. That formula is very, very important, right? So that's what we talked about in the previous lesson. Then, are there any questions before I move on to parallel circuit? Let's hope we are going to exhaust everything that we have in plan. Right? Are there any questions? Right, if you want to say something, you need to unmute yourselves, right? Now, so it means there are no questions. Then we will then move on to parallel circuit, all right? So on this lesson, I'm just going to share a screen with you, right? So that we can see whatever we are going to deal with. So under parallel circuit, we are going to look at cells in parallel. What happens to voltage if cells are connected in parallel connection? Then we are also going to look at what happens to resistance when resistors are connected in a parallel connection. So that's what we are going to look at today, right? So let's hope we'll be able to go through that. We were given 45 minutes, right? So let me then just share a screen with you. Right, we are going to share two pages here, or I've just divided it into two. So make sure that you have a pen and paper. Then there is that table, which is shown on the right side of my screen. We are going to make use of those tables as we will be doing some connections, right? So please make sure that you have a pen and pencil and the paper with you. Right. So whenever we are looking at a parallel circuit, right, we can describe a parallel circuit as a circuit that has got components which are parallel to each other. That's a parallel circuit. Components are parallel to each other, right? So if we are looking at, say, for example, a cell, if a cell is connected parallel to another cell, the same terminals are on one side, right? That's a parallel circuit. Otherwise, the components are parallel to each other. That's the basic definition that I can just give onto a parallel circuit. Now, so I'm just going to connect my components here. Then we are going to take some readings from the measuring instruments, right? So first of all, hello?
Bitte?
Right, I'm not hearing what you are saying. All right, let me then continue. So we are going to look at when we connect cells in a parallel connection, what happens to the voltage. Remember, a cell is the source of electricity. So we are going to find out what happens if we connect cells in a parallel connection. What happens to the voltage, right? So I'm going to make use of a resistor here. Remember, a resistor is any circuit component that consumes electricity, or it converts electrical energy to other forms of energy. Right. So please take note of the voltage. As you can just see here, I think, are you seeing my screen here? Grade 9 learners?
Yes, sir.
Okay, fine. How much, what's the PD of the cell?
9,0 V,
It's 9 point?
0 V
Thank you.
volts.
That's 9.0 volts, which is the same as 9 volts, right? So here we just have one cell, right? It's just one cell. We are not yet talking about a parallel circuit. I think it's clear there, right? Now, so we just want to know how much voltage is produced by one cell. So as you have just seen, one cell there produces what? 9 volts, right? So I'm then just going to connect it. How much current is flowing through the circuit?
Zero comma 0.9.
0.9. Thank you so much. So may you then complete it, just write it down somewhere. We are going to make some comparisons as we move, right? Right. So the current there, it's 0.9. That's the current that is flowing through the circuit. The voltage, it's what? It's 9 volts. So I'm going to complete this, the table that I have on my right-hand side. So as you can see in that table, we are having one cell and the voltage, we are saying the voltage is what? The voltage is 9, right? Now, then that's for our simple circuit. Then I'm going to connect another cell. This cell is going to be parallel to the other cell, right? Then we are then going to find out what happens to the voltage. Is the voltage going to increase or decrease? What do you think is going to happen?
It's going to increase.
The voltage across the resistor is going to increase.
Yes, sir.
Okay, we'll see, right? We are going to check and find out whether your hypothesis is correct, right? Then, now we are having two cells. Let's see how much voltage is going to be across our resistor. Right, there is my voltmeter, right? So we now have two cells that are parallel to each other, right? Now we just want to find out how much voltage is going to be across the resistor. Right? There we go. Now, how much voltage is across the resistor when we are having two cells? How much voltage is it? How much
9.
voltage is it?
0.62.
9.
Sorry?
9 volts.
It's 9 volts. We are looking at the voltage, the device or the component written what voltage. That's the voltmeter. I think we are clear there, right? So the voltage
Yes,
there,
sir.
you can just see is what? 9 volts, which means when we had one cell, it was 9. Now is still what? 9. Is there any change there?
No,
There's
sir.
no change.
There is no change, right? Remember, we are looking at cells in a parallel connection. Then I'm going to connect again another cell. Again, it's 9 volts. We are going to find out whether our voltage is going to change or not. Right, we still have our voltmeter, right? Is there any change?
No, sir.
Is still what? 9 volts, right? Right? Now, so
Yeah.
let me then connect the last cell, the fourth cell. Let's check again what happens to the voltage. Right. Is there any change on the voltmeter?
No, sir.
Right. So what can you now say about cells that are connected in a parallel connection? What happens to the voltage?
The voltage stays the same even if you put more circuits into it.
Right. So
More
we
cells into it.
sorry.
The
So
voltage does
in
not
a parallel
change.
connection, the voltage remain the same. Are we clear then? The voltage
Yes.
does not change. It remains the same. Now, so what I'm now going to do, I'm going to disconnect the cells here. I just want you to check something here, right? I'm going to connect an ammeter. I'm going to connect an ammeter, right? Now, when we are having one cell, right? There we have one cell. How much current is flowing through the circuit? How much current is flowing through the circuit?
Zero point 0.90.
It's 0.90 amps, right? And I think you can see there that we are having one pathway, right? It's one pathway. So the current is 0.9 amps, right? So what I'm going to do now is to connect the second cell in a parallel connection. And we are going to take note of what is happening on the volt, also on the ammeter or on the current, right? I'll connect the second cell and an ammeter. Sorry, grade 9. Right. I think you can now see there that there are two pathways, right? Do you see the two pathways?
Yes, sir.
Right. We now have two pathways. May you take note of the readings on the ammeters?
The readings are 0.41A and 0.49A.
All right. That's the current flowing through the what? The two pathways, right? So we've got two pathways that we have there. So the first one, let me say this is the first one, 0.49 amps. The second one is 0.41 amps, right? Now, so we are seeing here that the current is just what? Different. Please remember, we once said the longer the connectors, the more the electrical energy is consumed, right? So it's affecting our resistance here. No problem. Now, so this is the current produced by the first cell, and 0.48 is the current produced by the second cell. The cells are parallel to each other. Now, the current which is flowing through this circuit is flowing through this resistor, right? So the current that is flowing through 10 ohm resistor, we say is the total current from the two cells. I think that one is clear, right? Now, I'm going to connect an ammeter so that we measure the total current flowing through the resistor. Then we are going to compare the total current with the current produced by the two cells, right? Right. Now, how much current is flowing through the resistor? How much current?
0.9.
It's 0.9 amps, right? This is the total current that is flowing through the resistor, right? Now, let us now compare the total current flowing through the resistor as compared to the total current from the cells that are parallel to each other. What can you say about that? Anyone to try? Look at the current from the two cells and the total current flowing through the resistor. What can you say about that?
So when you add the currents like 0.42 and 0.48, they make 0.9 amps.
Right. That's true, and that's correct. Thank you so much. Now, so whenever we are having cells that are connected in a parallel connection, what then happens here is each cell is producing its own what current. So the sum of the current of the cells that are connected parallel to each other will add up to the total current flowing through the resistor, right? So that must be known. So we are having two pathways, which simply means the total current flowing through the resistor is distributed or is shared among the two pathways, right? Now, for interest's sake, let me then just quickly show you again the ammeter reading. If we connect again another cell parallel to the two cells, please take note of the current that we are going to see there, right? I've connected the third one, right? So if you add the current, the three current of the cells that are parallel to each other, does it add up to the total current flowing through the circuit? May you quickly check that?
Yes, it does.
Does it add up to the total current flowing through the circuit?
Yes, sir.
Right. So what we are just saying is whenever we are looking at a parallel circuit, current is distributed, right? So in this case, 0.9 is the total current which is distributed onto the three pathways. So we've got 0.39, the other one is 0.35, and the other one is 0.16. So when you add these two together, you are going to come up with the total current flowing through the circuit. That's for a parallel circuit. Right. Are there any questions before I move on to, or whilst I'll be moving on to the other diagram now?
No, sir.
Fine. So this was about cells. Now, let us now look at resistors that are connected in a parallel connection. So I'm going to get rid of all this. All right, fine. Now, I'm going to make use of one cell. Then this cell is connected to an ammeter. Then I'm going to connect, I will connect resistors. Now, first of all, let us look at one resistor. By using one resistor, how much voltage is across the source of electricity? How much is it?
0.9.
It's 0.9. And our resistance, the resistance in the circuit is 10. So let's find out how much voltage is across one resistor. How much voltage is across one resistor?
10.00.
Right. I'm going to complete the table that is on my right-hand side of my screen, right? It says that's resistors. The number of resistors we are having what? 1, right? Then we have got VT, that's the total voltage. The total voltage, we are looking at the voltage supplied by the source of electricity. And we said it's what, 9.0. So I'll just write 9 volts there, right? Then we have got the total current that is going to flow through the circuit, right? This total current here, it's the current that is flowing through the circuit, which is 0.9, right? As you can see, the ammeter next to the cell is 0.9, and the ammeter reading onto connected onto the resistor is also 0.9. Remember, we said in series circuit, current flowing through the components is the same, right? So that's what we are seeing there, right? Now, so the other ammeter connected to the resistor becomes my my A1, which means ammeter 1, which is also 0.9. Right? Now, I'm now going to connect a second resistor, right? I'm going to connect the second resistor. Then we are going to take note of the total voltage supplied. Then we are also going to do some measurement of current flowing through the circuit. Are you still with me?
Yes, sir.
Fine. So I'm going to connect a second resistor. Right, there we go. We have got two resistors. Each one is 10 ohms, right? Now there are two resistors that we have, right? And you can, I think you can see there that we have two pathways, right? Right? Now, what is the current that is shown by the ammeter connected to the connected to the cell? What is the current there?
1.80.
Thank you. Which means that one is the total current flowing through the circuit. So I'm going to enter that value on AT, which means it's 1.8 amps. That's the total current. Then what is the total voltage supplied? What's the total voltage? What is the voltage produced by the source of electricity? All right, for the sake of time.
0.9.
Thank you. Sorry, it's what?
0.9.
If you check 0.9 there has got A. It has got simple A, which means it's current, right? Voltage is measured by a voltmeter, and a voltmeter is represented by V. So it's what? 9 volts. That's
9.
Thank you. That's the total voltage produced by the cell. And the total current flowing through the circuit is 1.8 amps, right? Now, if you check, what is the current flowing through the first 10 amps? So the first 10 ohms. What's the current there?
0.9.
It's 0.9. So you can now see here that our current is 0.9 as is shown on the first resistor. What about the second resistor? How much current is it?
0.9.
It's
It's the
also
same.
0.9. So what can you say about the current when we are comparing it with the total current for the circuit and the current from each resistor?
Come again, sir.
Let's compare the current. We have current that is flowing, right, through the source of electricity and the current from each resistor, right? Let's compare that. What can you say about that?
The resistor has more ammeters than the battery.
The resistor has got more?
Ammeter.
This, the one written current, right, is the ammeter. So the reading there is 0.9 amps. The other ammeter is also reading 0.9 what? Amps. So let us now compare those 0.9 amps shown by the two ammeters as compared to the reading on the ammeter connected to the cell. Are you still with me? All right, fine. For the sake of time, remember we said whenever we are having a parallel circuit, current is distributed, right? So since we have resistors that are connected parallel to each other, it means that the sum of the current passing through the resistor will be equal to the total current that is produced by the source of electricity. Quickly find out whether that statement is true. Just add 0.9 amps plus 0.9 amps. Does it come up to 1.8? Quickly check.
Yes, it
Yes, sir.
does.
Right? So we are saying there, as we connect more resistors in a parallel connection, current is shared, right? But now, what is happening to the resistors? If we connect resistors in parallel connection, what happens to the resistors? Someone to give us a hypothesis of some sort. What is happening to the resistance? Is it increasing or decreasing?
Decreasing.
You are saying it is going to decrease. Right. So what I'm going to do here is to try and set up another diagram. And on that diagram, I'm going to have a cell. Then I'm also going to have a meter reading, and that meter reading must read 1.8. Then we are going to find out which resistor will give us that current of 1.8, right? Let's hope the time will allow me to finish that. So I'm going to come up with a setup, and in that setup, I must have a resistor that will allow 1.8 amps to flow through it, right? We are trying to find out one resistor that produces 1.8 amps, right? Now, as you can see on the second diagram that I've just constructed there, the resistance is 10. Then the current is what? 0.9. Are we together there?
Yes.
Fine. Then I'm going to change the resistance in such a way that the current will increase up to what? 1.8. Then that resistor, right, will be having the same resistance as to the resistance of the what? The parallel circuit, right? So I'm going to try and increase the resistance here. When I increase the resistance here, what happens to the current? Right? It's now equals to 13. Current is decreasing. I think you can see that, right?
Yes.
You can set up. Now, which simply means in order for me to come up with 1.8, I must reduce the resistance. I must have 1.8. Oh, past the 1.8. Right. So what it means, the resistance that we have on the resistor, right, is equal to the resistance of the what? Of the circuit where we have two parallel resistors. So how much resistance is it?
5.
The resistance is now what? 5. So it means
5.
that if we put two resistors parallel to each other, the total resistance is going to be what? Is going to be reduced.
Yes.
You see that, right? So when we connect
Yes.
two resistors parallel to each other, resistance is going to be what? Reduced.
What do you mean?
Thereby allowing what? More current to flow through the circuit,
Circuit.
right?
Mm-hmm.
Now, I'm going to connect the third one. Let's find out whether the resistance is going to be further reduced or is it going to be lower than 5? Because we are saying the more the resistors that you connect in series, the more the resistors that you connect parallel to each other, the lower the resistance, right? And the higher the what? Current, isn't it? Let's find out whether that is true or not. I'm going to add another resistor here. Right? What is the new current now? The total current?
2,78.
Now what?
2,7.
2.7, right? Now, for us to have 2.7, is our resistance going to be lower than 5? Is it going to be lower than 5?
Yes, sir.
Right? So let's check now. What is going to be the total resistance if 3 resistors are connected parallel to each other? I'm going to lower the resistance.
4,5.
Right?
4.5.
It's going to be,
4.5.
is it going to be 4.5?
Yes, sir.
Yes.
Now it's 4, right? For 4 is 2.27, which means it is lower than that, right? Then 2.57 is 3.5, right? I think you can see there that if we connect the 3 resistors in a parallel connection, the total resistance for the circuit will be lower than 5, right? So if I continue to reduce it, then it goes to what? The current goes to 3, right? The resistance is now at 3, right? So which simply means the total resistance for 3 resistors connection and 5. I think it's right. Now, so far, are there any questions on parallel circuit?